back, everyone. Up now we have Jenny. Hi, Jenny.
Hi, Jenny.
And she'll be talking about quick production scale data pipelines, so let's make her feel welcome.
Cool. Hi, everyone. My name's Jenny, and I'm a data scientist at a Kiwi tech startup called Multitudes. We do team analytics and team health data to help engineers get better insights about how their teams are going and how to better improve processes using data from integrations like GitHub, Linear, Jira, that sort of thing. So today I'm here to talk about how everyone in this room can build quick production scale data pipelines by keeping things simple and scalable with Python. So just a bit about me before we start. I started coding when I was about 8 at the OG Coding Academy, Neopets. And there I learnt HTML and CSS and thought that was coding. And then that love of coding took me all through uni, school, actually here in Christchurch. So it's really nice to be back here in this beautifully restored arts centre. But by the time I got to uni, I'd picked up like a lot of other interests and then did this quite chaotic degree. But by the end of that, I just sort of decided that coding's my true love. And I just got my first job at Xero. So I worked as a graduate developer, but then quickly sidestepped into data science because it linked up with a lot of the mathematical modeling stuff I'd done at uni. And that was awesome. Xero gave me a really good grounding on how important scalability is. With over 1 million customers and sensitive financial information, it's just really critical that things are kept tight and scalable and reliable. So that was an awesome foundation for me to start. And then 2 years ago, I had the opportunity to join the founding team of Multitudes, which is the startup I'm with today. And that's been a wild ride as a data scientist in a startup ever since. This is where I'm continually learning the importance of keeping it simple. So we're very restricted on time, but we also need to build things to good quality if we want to build something that customers are going to love. So we're always having to be super efficient with where we invest our time, and this is where the keep it simple principle has always just come into play in every layer of what we do. And that's what I want to talk about, is how keeping it simple and scalable can really help you build your products and ideas faster and better. I first want to start off with a little icebreaker. So I just want to get an idea of the preferences in the room. We've talked a lot about all the different ways you can do things in Python, and I wanted to have a visual illustration of that. So could I get some hands up for who prefers classes over functions? So hands up for classes. Oh, interesting, yeah. Functions? Cool, yes, all the data scientists, yeah. Confession, at Xero, I had no idea what a class was, and I'd spent my entire uni degree writing MATLAB scripts. And then, I just felt like a total imposter being I write in Python, but I have no idea what an object-oriented thing is. So if you're sitting here and you're what am I doing at a Python conference? It's fine, I've still got a job, you'll be okay, yeah. How about map versus list comprehensions? Map? All the async people. List comp? Yes, I mean, not that that's the right answer, just interesting, very interesting. Okay, package managers. I've never heard of PDM before writing this talk, but it's a thing apparently. So poetry? Cool, a few people. PPEM? Yes, and PDM? No one, okay, cool. Well, apparently it's a thing, so that's another thing you can have choice paralysis about. And last one, code formatters. Auto pip8. Cool. Black. Single string or double string? Just, yeah. Prettier. Cool. Yeah, so that was a fun little activity, but I think it does highlight one thing, and that's that there is a lot in this Python ecosystem. I think that's been a big theme in the talks this year. Christopher's keynote yesterday talked about how constructs enforce one simple, opinionated way to build things so that it's easy and maintainable for people. And then Grant and Ben's talk about the win of Python mentioned that the sheer number of options you have when it comes to implementing anything can really get in the way of the zen of Python. And then when you're building a web app or a machine learning system or a data processing pipeline, Python's not even the whole picture. You've got infra, CI/CD, front-end frameworks. And don't get me wrong, like this is one of the things I love the most about tech is just how much there is out there. But it is kind of overwhelming. And sometimes this wealth of packages and tools get in the way of your core goals. And maybe you're just a hobbyist that wants to get your side project up and running, or you're someone from an academic background who's diving into data wrangling for the first time. Or maybe you're a data professional and you need to build an MVP in a really short space of time. So yeah, tons of tools can end up being blockers to your workflow. It can be overwhelming with the number of choice, and that can be doubly hard if you're building a data product, which, let's be honest, everything is a data product nowadays. So you've got all the complexities of a web app, plus all the data pipeline and data science stuff around it. You can get blank canvas syndrome. So how many times have you looked at a legacy code base and thought like, oh my God, like if I have a startup, like it will be perfect from the start. But that pressure that you put on yourself, and whether that's like real pressure or sort of made up in your head, that pressure to get it right is really high. And then all of this culminates into something that we don't talk about very often, but has a very real impact on your experience of coding and work, and that's imposter syndrome. It can be really hard to feel like you belong or that you're like good enough when there are all these shiny new toys and you're just scrambling to keep up. It can really crush your confidence when you feel like the only data scientist who hasn't used TensorFlow, Keras, and PyTorch. That's me. And the impact of this on our work is subtle, but it does have macro-level effects. So people second-guess themselves often when they want to bring ideas to the table at a meeting, and that limits your team's creativity and their ability to problem solve in a sort of lateral thinking way. We've heard a lot about people who want to apply for a job but then get put off by the massive list of tools. And studies have shown that women are more likely to be affected by this than other marginalised genders. Maybe you're holding off on launching your idea because you feel like you have to know all these technologies before you can even give it a go. And so these feelings are real and they become real blockers for people. On the other side, it can be tempting to just shove the best of everything into your new project, but taking on lots of tools can also slow you down. There's the cost of setup, the cost of maintenance, and some managed tools just cost a lot of money, and that might be a constraint. So none of this, the feelings of imposter syndrome or all of these costs, which might not even be necessary, are not conducive to a creative, exploratory, and fast innovation environment. So in the next bit, I'm going to show a bit about how we went about choosing a tech stack for our data pipeline, which has been foundational to our data analytics product. Firstly, what is a data pipeline? Because that word kind of sounds a bit intimidating to me. But data can be something as simple as a single CSV, or as complex and messy as 3D data cubes of galaxies. And a pipeline is basically a chain of operations on data, like you see here. So obviously there are very legitimate use cases for complex data pipelines and architectures. Otherwise, all the tools that I showed before wouldn't be so popular and necessary in a lot of cases. But I just wanted to illustrate that you don't have to be intimidated by the concept as a default, like I was. Yeah, when you think, oh, like I can't build a data pipeline, you probably can, and you probably already have. You don't need to know all the latest big data tools to get started. Yes, exactly. I'll illustrate this with an example from my own experience. So Multitudes ingests data from online tools, processes it, and then presents it in a dashboard for people to log into and use. So it can't exist without data pipelines. When I was umming and ahhing about whether I should join the startup, I was telling myself, oh, but like I only know Python. I don't know if like I can offer that much to the startup team. So I knew that building data pipelines and basically doing a whole lot of data engineering work as well would be foundational to the product. And I thought that my simple skill set wouldn't be enough to contribute anything of value. But as Lauren, our CEO, said, she was like, well, I'd rather hire someone who's excited about what we're doing and a good learner versus someone who knows more things but won't be as eager to learn. And I think especially in a startup, we've learned that where things change all the time, the ability to learn is number one. And we can all back ourselves to do that. Like we're coders, we're hackers, whatever you want to call us. Like learning new stuff is our entire job. And so just start simple and start with the tools that you've already got. And so that's what we did. So here's an example of one of our data flows. So let's say we're calculating review wait time, which is how long a team might take to wait for a response on their pull requests. Customers give us access to their GitHub metadata by installing our integration from the app marketplace. And then from that point, the GitHub webhook sends us real-time events about pull request metadata, so like the comments, reviews, minus the code. And then this raw data gets cleaned, processed, and then enriched with custom metrics like review wait time, and then stored in our database for APIs to consume. And just on a side note, I know there's some people who have been talking about mining software repositories, and I recently did some analysis on how to build like inclusive open source communities using some insights from data, and I learned a lot in that process, so I wrote like a tutorial with some code snippets in case you're interested. It's like a draft, but you can get like the preview link. So this is our V1 pipeline that was built in Python with pandas, hosted on an AWS Lambda, and deployed with Terraform on Circle CI. There was also an AWS PySpark script to flatten the nested JSON. And so what does this look like in practice? So here's a simplified view of what the code looks like. So you get command line params, that gets sent to this main function. You auth, get organization data, and then loop through each org, and then get the data for that organization, process the data, and as you can imagine, this is like 90% of the code base with like a bajillion lines for data cleaning and validation, but neatly encapsulated in this simple example. And then you write that data somewhere to a database. We've also got a bit of logging, so we log to CloudWatch, which I haven't included here because it's on like every line, and we send a Slack alert. So that's it. This is a fully functioning production data pipeline, and I think most people here would have been able to follow that and probably write it yourself. I just want to point out, though, that building things fast doesn't mean we're building poor quality. So we picked this Python and AWS stack specifically because we have the knowledge and the experience to build it with best practice or good enough practice, and we can do that really easily and quickly. Taking Laura's advice on being vulnerable about testing, I admit it wasn't perfect from the start. I didn't wear like a 3-color hat every time I coded, but we did have unit tests from the start, and they were part of our PR checks in our CI/CD pipeline. So because we'd set everything up, it became much, much easier to easily update our pipeline as our code base and our needs grew and changed. So this upfront cost paid itself off extremely quickly. So why did we choose this stack? Firstly, we needed something that everyone could pick up. We're a small distributed team. At the time, we were working part-time alongside our full-time jobs to get this up and running. And we knew that everyone would be touching every part of the code base and often working random hours on their own, so they can't just turn around and be like, hey, how do you do this thing? So we needed something that's easy to learn and readable for everyone, which Python's renowned for. Our team happened to also know a bit of R, but the other things we considered, like Node and Go, half the team wouldn't have been familiar with it. Data wrangling is also obviously important to us, and so we needed robust libraries for crunching and doing stats. It was also, so Python was also natively supported on the infrastructure we wanted to use, which was another decision based on what we already knew, which was AWS Lambda. And lastly, we needed something scalable, and by scalable I mean something that's going to fit with our future needs as our product grows. And we knew that, we weren't sure 100% how, but we could make some educated guesses that the data we process would increase, the kinds of processing we do might become more compute intensive, and that there might be more need for reliability monitoring and logging. And so an obvious alternative was R for data wrangling, but it was clear that Python had a much richer ecosystem for big data tools and all of that sort of robust production scale development things. So that's what we decided on. Yes, Python. But the most important factor in our decision was really just picking what we knew. So adding in too many other tools all at once would have really limited our ability to collaborate and support each other across domains. So if you're a full stack developer who's jumping into data engineering for a bit, or a data engineer who's being pulled onto some APIs, Python really let us do that easily alongside our other tools. And this was at a time when developer hours was a very limited resource. In the end, our V1 pipeline worked. It got us the feedback and engagement we needed from our earliest beta testers to raise investment, and that was just the next stage we needed to get to hire a full-time team and then to rapidly iterate on our fledgling new product. So now you've got an MVP up and running with a simple stack, great. How can we look at layering on new features and building on that simple foundation? So with new features, you also layer on more tools to handle the complexity that might come with that change. So the needs of our humble data pipeline have changed a lot in the 2 years it's been in the wild. Fortunately, because of those earlier decisions around scalability, this has been reasonably easy. We've built a ton of features since that first blank slate, and so that's meant new libraries, new code, and that's brought with it a lot of requirements around refactoring, better separation of concerns, things that we didn't need before and rightfully didn't spend time on because we didn't need it at the time. We also have more customers, so reliability is really important. So logging, monitoring, Python has great logging packages, plus I've got a super nice Slack SDK for custom alerts. This is an example of what our alerts look like in January 2021, and this is what it looks like now. And I've had to blur everything out because it's commercially sensitive, but just trust me, that's like a lot more comprehensive. We also process a lot more data than we did. So everything used to fit into that 15-minute limit on Lambdas before. Now we've moved to ECS. In the future, we might also need to parallelize our data, and that's easy to do with multiprocessing or just spinning up more instances. And then our features are getting more sophisticated and complex. So I've introduced DBT, Snowflake, and we might end up going for something like Airflow as well in the future. And all of this has been really easy because we're in Python. So it let us have a simple stack at first, but then layer on tools and packages that we could scale with incrementally. So we've talked about simple, scalable data pipelines in a greenfield project, but what about other places where you can apply this sort of thinking? A brand new startup isn't the only time you can make the most of a simple data pipeline. We found that so for one example, we've been using it in UX research. We found that when users test features with real data prototypes rather than just a static mock-up, they give much richer and more honest feedback because they understand and have context about their own real data. This required data to be processed in sometimes a semi-automated manner, but it didn't need to be fully productionized. So for example, a couple of weeks ago, we were brainstorming how we wanted to solve the customer problem of wanting alerts about blockers in their workflow without having to go and use another tool. It took under a week to toss around the idea of a Slack alert, to writing a Python script that looked kind of like this, to generate daily alerts, run some checks, and then just yeet it out the window to user testers who could give feedback with their own data, and it just validated our new feature ideas really quickly. That's kind of what it looked like when that script ran, and it just sent it to my test channel. Because it's already scripted up, we just need to add a few more tests and then all the infrastructure around it to productionize. It was very cheap to spin up, and the feedback from customers has been really positive, so we've actually been able to fast track this feature to production, and I'll be starting work on it tomorrow, on Monday. So how does this relate to scaling? Regardless of what stage your organization's at, there's no denying that fast feature validation is really key to delivery. It's kind of meta, but running UX research with simple, scalable prototypes of new features helps your whole product as a whole scale as well, because you can iterate and respond to your customer needs much faster. So if you know Python, and presumably you're a coder, so you clearly have great Googling skills, you have everything you need to get started on building a data pipeline for your data product or within your company to test some new ideas. These are just the 3 things that I want to leave you with. So firstly, keep it simple. Our team was able to ramp up quickly and get beta testers trying out our ideas and giving feedback because we chose a stack we were familiar with. It was simple to maintain and iterate on quickly. So you don't need to feel like you need to know all the fancy stuff to get started. You just need to get started. Yeah, and I'm constantly surprised by the number of times that there's been a very simple solution to a customer problem, and it's taken actual discipline and rigor to recognize that solution rather than being tempted by much shinier but more complex solutions that no one actually wants. Secondly, remember to keep it scalable even if you are focusing on simplicity at first. It's important to choose an ecosystem that has good support for your future use cases. And the last thing is to back yourself. Don't let imposter syndrome get to you. Data pipelines are just like anything else you've ever built. They can be as simple or as complex as you want them to be. And rather than agonizing over the tools you don't know, how about just get started with the tools that you do know? Remember that your first prototype is just that, a prototype. It does not have to be perfect. And just have the confidence that if the needs of your product changes, that you'll be able to change too, just like you've been doing all along in your career as coders and developers. So yeah, excited to hear what people will build next. Thank you for your time and attention. That was my talk. And quick plug, so Multitudes is an ethical team analytics tool. We're always looking for values-aligned people who are interested in giving feedback on our product through our invite-only beta. So if you're interested, just get in touch or check out the links. Thank you.
That was really cool, and your slides look gorgeous.
Yeah, just love Canva, Canva everything.
So we do have a couple of minutes for questions. Bueller? 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 No, you explained everything absolutely wonderfully and beautifully, of course. Oh, there is one.
So you mentioned pull request data. What other types of metrics do you use?
Yeah, so time to merge is a key one. It's related to the DevOps metric of lead time, which shows sort of flow of work and delivery. Out of hours commits is one that we use for well-being, so seeing if people are doing late nights and things, and then that feeds into our one-on-one view where you can use that data to be like, because it's kind of awkward to be like, oh, I've been working really hard, can I have a day off? But if the data's right there, it's like, oh, did you do like 3 late nights last week? How about we talk about that? Yeah, so lead time, out of hours work. Collaboration metrics, so we have a lot around giving feedback to each other, especially because we want to make sure that everyone is receiving an even amount of feedback, or the feedback that's appropriate for them. So we have a chart called feedback flows, which is like a Sankey diagram, and it shows who's talking to who through comments, and that's just to show the true structure of the organisation, where are the knowledge silos, who works closely with who. We've just released one called participation gap, which is around, so a key indicator of team performance is psychological safety, and then a key indicator of psychological safety is share of voice, so how comfortable everyone feels with bringing their voice to the table. And so one way of measuring that is how, if there's like an equal sort of distribution of how much people are giving feedback on pull requests and things, which we realize is really limited. So another big thing in our data ethics principles over here is that everything we do, we try to encourage people to bring their human context. So all the insights that we raise at the top, they're all framed as questions and conversation starters. So rather than being like, your time to merge is bad, we sort of ask questions that might prompt what else could be happening. Like, oh, your time to merge is trending down, up, because up would be bad. What might be causing that? And here are some links to resources or other contributing factors. So yeah, we try to focus on sort of the DORA DevOps metrics plus a few wellbeing collaboration ones in as well, and then layer on top with human context type stuff.
Are there any other questions? Oh wow, you have many questions.
Do you use your own tools for your own development?
Yes, yeah, we dog food all the time, use it for one-on-ones and retros and things like that.
Run, 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 run.
Are you looking at anything other than the GitHub metrics at the moment? You mentioned sort of Slack messages, and does it sort of pull stuff from other sort of communication channels like Slack or Discord or Microsoft Teams?
Yeah, so the Slack integration we've got at the moment is only one way. It's just for sending alerts, but in the future we would be interested in ingesting data as well. But before that, the one that we've just released is Linear, and Jira will soon follow after that. So Linear is like Jira basically, but an issue tracking tool, and the feature that we've first released is types of work. So who's getting tied down with all the glue work around bugs and chores, how fast is your team getting through feature work velocity versus chore and tech debt velocity, that kind of thing. Yeah, so those are 2 other integrations. Would love to integrate with GitLab, Bitbucket, Teams, all the rest of it in due course when we become a massive startup.
Any other questions? Let's give Jenny another great big hand, please.